Hello students, it is our sixth video, and in this video we will discuss what are the limitations of a chemical equation, and also we will discuss how can we make a chemical equation more informative. Today we will discuss what are the limitations of chemical equations. Limitations of chemical equations. So in this part we will discuss that from a chemical equation we do not get all the information properly. For example, the physical state. Physical state, that means the physical state of reactant and products cannot be known by a chemical equation. Next is energy change. Energy change in this, that is, chemical equation does not provide information about the energy change. That means whether the reaction is exothermic or endothermic. Next is reaction conditions. The reaction conditions, no information is given about the temperature and pressure conditions of a particular reaction. Next is feasibility. Feasibility, that means the actual word is feasible from, the meaning of feasible is accessible. That means whether the reaction is possible or not. So feasibility, that means no information about the feasibility of a chemical reaction, whether the reaction is possible or not. And next one is speed of reaction. So from a chemical reaction we do not get any information whether the equation is slow or fast. Now, extent of reaction, that is, no information can be given about the extent of a reaction. Now we will discuss how to make the chemical equation more informative, and we can make a chemical equation more informative by following changes. For example, solid, that is physical state of reactants and products, can be mentioned after the symbol of element or the formula of the compound. In bracket, the solid is represented by S, small s, liquid by small l, and gas by small g. For example, here we can see that is carbon dioxide gas, that is in gaseous form. That's why we have represented this one in gas by using small g. This is solid. Calcium carbonate is solid and it has been indicated by small s, and water has been indicated by small l. And one more state we used to represent, that is aqueous. The aqueous, the word aqueous means the solution prepared in water. The solution prepared in water is known as aqueous. So here aqueous is represented by letter A, small aq, by letter small aq. Now we will discuss the gaseous products. So gaseous products form can be represented by an upward arrow. Like here, when zinc reacts with sulfuric acid, it forms hydrogen gas. The hydrogen gas can be represented uses upward arrow. In the same manner, when precipitates are formed in a reaction, it can be represented by downward arrow. Here you can see, here we have represented calcium sulfate, which is a solid. So it forms in the form of precipitate. So this has been indicated by downward arrow. Next is in case of, we are discussing the exothermic and endothermic reaction. These are also known as thermochemical reaction. The thermochemical reaction, that means where involvement of change in heat takes place. It may either release heat, which is known as exothermic, or it may need some heat, which is known as endothermic reaction. So in this case, if heat is liberated, so this heat can be represented simply by writing heat, or we can write heat energy. It can also be written as heat energy, or simply energy. For example, when nitrogen react with oxygen by taking heat, it forms nitrogen oxide, monoxide. So here it takes 3000 degrees Celsius of energy. So this is also the indication that it takes heat. So we used to represent heat by writing heat. And next is, if it is exothermic, it will liberate heat, like here. In this case, here heat has been represented by using heat. So these are, it may be either exothermic or endothermic. So all the decomposition reactions are example of endothermic reaction. Or keep this thing in your mind, that all decomposition reactions are example of endothermic reaction, whereas all the combustion reactions are the example of exothermic reaction. And exothermic reaction are also like respiration is exothermic reaction, and endothermic photosynthesis, that is the example of endothermic reaction, and electrolysis of water, that is also the example of endothermic reaction.